viewers. Welcome to Uncle Chamberlain Educational Channel with your anchor man, Uncle Chamberlain. We are here this morning to further give you examples on indices. You know, the last time we talked about the laws of indices, and today I'm here to show you how you can apply the laws in solving questions on indices. Okay, let's go to the board. Today we will evaluate two questions on indices, and after this you can go ahead by picking on questions on indices on your mathematical textbook, and anyone you find that you are able to do, you can send it to me through the educational channel so that we'll look at it together. But today, let's take on the two questions on indices. Question number one. Question number one. Question number one. Evaluate eight raised to power 1/3 multiplied by 5 raised to the power of 2/3 all over 10 raised to the power of 2/3. This is number one question. Now, if you want to evaluate this, what you think of is to ensure that the base number when multiplied by any number will give you exactly the base number in the question. What I'm trying to say, we know that if you have 8 here, 8 could be expressed mathematically as, when you have 8 here could be expressed mathematically as 8 be expressed as 2 raised to the power of 3. That is 2 times 2 times 2. 2 times 2 will give you 4. 4 times 2 will give you 8. So also 10 here could be expressed as 10. Could be expressed as what? It could be expressed as 2 times 5. 2 times 5 will give you what? 10. So having known this, you can put these factors of 8 and 10 into the mathematical equation so that you will have all bases the same. Now, if you want to put this into here, we'll now say from the question, this is the question. If you want to put this expression now of 8 and 10 into the question, you will now have 8, which is 8, so that's 2 raised to the power of 3 into the cube root 1/3 times 5 raised to the power of 2/3 all over. You know, we have 10 here, but now we're going to make 10 as 2 times 5. Let's say 10, which is 2 multiplied by 5, all to the power of 2 over 3. Let's say this is equation 1 now. Then this one is equation 2. You can see that when you can looking at equation 1 and equation 2, they are the same. But the 8 and 10 there have been expressed by raising 2 to 3 to get 8, then multiplying 2 by 5 to get a 2 over to get a 10 in equation 1. Okay, then further applying indices rule, you will now have further application of indices rule. Of indices laws, further application of indices law, we now have the following. When you have 2 raised to the power of 2 of 3, 2 raised to the power of 3 to give you 8 into the cube into the power of 1 over 3 in indices, this simply means in indices this means two to the power of 3, which is 8, multiplied by 1 over 3, and this will give you 2. The numerator is 3 and 1, while the denominator is 3. So what you have, multiply the numerator, then base divided by the denominator. So you now have 3 times 1 is 3, all over 3. This is what you have. Therefore, 2 into 3 brackets 1 over 3 is equals to what? 2 into 3 all over 3. 2 into 3 all over 3 is same thing as what? The same thing as this cancel is 1. So you now have 2 to the power of 1. That's for that. Further expression of this, you will note that if you now put this into the equation, you will notice this. This is what you have when you have a 2 over 3, 2 raised to the power of 3 all over 3. You have a 2 to 1. Then for the one at the bottom, where you have a 10 in raised to the power of 2 over 3, where you have the denominator, for the denominator side, where you have 10 into 2 over 3, which is expressed as 2 times 5 into the power of 2 over 3 is same thing as 2 into the power of 2 over 3 times 5 into the power of 2 over 3. This will give you this. Ten into the power of 2 over 3 will give you 2 times 5 into 2 to the power of 2 over 3. This will give you 2 into 2 over 3 multiplied by 5 into 2 over 3. This is what you get if you further express it. Now, if you want to put this back into the original equation, you will now have this. Let us put it back into the original. Let's put it back into what we have in equation 2. You will have the following. If you put it back to what we have in equation 2, you will have this. You now have you know that this will give you this. So you now have 2 into 3 1 over 3 multiplied by 5 2 into 3 all over 2 into because this one could be expressed as this 2 into 2 over 3 multiplied by 5 into 2 over 3. Yes, this is what you have. So equation 2 can be written as this to give you equation 3. Equation 2 can be written as this to give you equation 3. Now if you have equation 3 here, you can solve further. Solve further. If you have equation 3 as this, we can solve further. So we now have what? We have 2. This will multiply the denominator to have 3 over 3 multiplied by 5 2 over 3 all over 2 over 3 multiplied by 5 2 over 3. Now in indices rule, once you have the same base with different index and they are divided, the same base, once the index move up, if the index is moved up of the same base, there will be a sign of subtraction at the index. A sign of subtraction for the index that is moved up. Like here, we have 2 to the power of 3 over 3 times 5, 2 times 5 multiplied by 5, 2 to the power of 2 over root 3, all over 2 again to the power of 2 all over root 3 multiplied by 5 to the power of 2 all over root 3. Now we have the same base. These are the bases. We have 2 here, we have 2 here. We have 5 here, we have 5 here. Now what we would do is to move, because there is a sign of division here, we have to move their index up. This index up, that's their power up. If you move the power up, it will become subtraction, such that you will now have 2 to the power of 3 over 3 minus 2 to the power of what? 3. To the power of 3 multiplied by 5, pick the one of the 5, to the power of 2 minus this 2 to the power of 3. This simple subtraction will give you, what is the denominator here? The denominator that is common to the number 2, to the base 2, is 3. So you now have, you pick 2 again. The denominator is what? 3. 3 into 3 is 1. 1 times 3 is 3. Minus 3 into 3, 1. 1 times 2 is 2. Multiply by, pick 5. What is the common denominator? Common denominator is 3, 2. 3 into 3, 1. 1 times 2 is 2. Minus 3 into 3, 1. 1 times this 2, give you minus 2. So we now have further solving. You have 2. This minus this is what? Is 1. We now have 1 all over 3 multiplied by, this time this is, this minus this is 0. So you now have 5 over 0 over 3. This is what you now have. That's what you have. The further expression will give you this. I am doing this so that you will understand properly how the indices work. Because if we are to shorten it, I can shorten it, but I'm giving you this stage development so that you know how it works. So from here, I now have 2 raised to the 1 over 3 multiplied by 5. This 3 divided 0 is 0. So you now have 5 raised to the power of 0. In indices, anything raised to the power of 0 is what? Is 1. So what you now have is 2 raised to the power of 1 over 3 times 1. Because 5 to 0, 5 to the power of 0 is 1. So 1 times this, you still have 2 raised to the power of 3. And this is equals to what? Roots 3 root 3 2 root 3 equals to 2 root 3. Equals to 2 root 3. This is your answer. That's your answer. So this is for the first example. Now we are going to the second example. The second example, I won't go into details like this. Second example, we have to rush it so that we'll have time for our unloading. In our second example, we are told to evaluate. Second example, evaluate root 3, 6, 4 arrow raised to the power of 6 to the power of half again. This second example. But what I want you to know is that if you have a number 64, you think of any number. This we'll call it in mathematics. We think of the prime factor, a prime factor of 64. If you have this is the solution now. If you have 64, you think of the prime factor of 64. What is the prime factor of 64? Let's take 2 for instance. If you say 2, you now say 2 multiplied by 2, 4, multiplied by 2, 8, multiplied by 2, 16, 2 times 2, 4, times 2, 8, times 2, 16, multiplied by 2, 32, multiplied by 2. This will give you 64. This is equals to 64. So how many 2 do you have here? We have 1, 2, 3, 4, 5, 6. So 64 could be expressed as 2 raised to the power of 6. I don't know if you understand it. 64 could be expressed as 2 to the power of 6. So if we agree on this, this could be put into the question here so that we can solve easily. So we now have, if 64 could be expressed as 2 to the power of 6, we now have from the question, we now have root 3 bracket open, 2 to the power of 6 arrow to the power of minus 6 bracket close, half raised to the power of half. This could be expressed further. This could be expressed further by saying by saying 2 to the power of 6 arrow to the power of minus 6 to power half the power of minus 3 to the power of 1/3, because we have removed the cube root, so it becomes 1/3. So if it's 1/3, this will multiply this first. You have to treat this first, so that you now have 2 to the power of 6 arrow to the power of minus 6 into, if this one multiplies it, you now have a half multiplied by 1/3. That's what you have. So from here, there, we now have let's be fast this time because we're running out of time. From there, you have bracket open, 2 into the power of 6, arrow minus 6 into this side is 1, this side is 1 over 6, 1 over 6 into the power of 1 over 6. If it's to the power of 1 over 6, 1 over 6 will come this way. So you now have 1 over 6 will now multiply 2 to the power of 6 times 1 over 6 multiplied by arrow minus 6 multiplied by 1 over 6. 6 will cancel out 6. 6 will cancel out 6. So you now have 2 to the power 1 multiplied by arrow minus 1. 2 to the power 1 is 2. So you now have 2 times arrow minus 1. Arrow minus 1 will be, if you express it further, you now have 2 all over arrow as your answer. So these are the two examples that I have your way today. With this example, if you follow them closely, you will know how to apply the laws of indices whenever you are faced with any questions. So I want to end up today by thanking you for being a part of my program, Chamberlain's Educational Channel. I want you to subscribe, like and comment on this program so that the program can come your way as I went you. Thank you very much.